One of my students came back from the meeting in Seattle where the Charlie Foundation was beginning to organize, and it was starting the organization. There was a meeting related to the, so they came back very enthusiastic about this keto stuff all over again. And I said, well, why not? We had a few extra bucks. So we put these mice on the ketogenic diet, and their seizures stopped. But we developed a strategy for mouse work with ketogenic diets. We were very comprehensive. We measured blood sugars after a 3-hour fast. We did a lot of things to prove that it was the shift in the ratio of glucose to ketones. And it really didn't make any difference what the genetic background of the animal was. So we were noticing that regardless of whether this mouse may have seized for that mutation or this gene defect or that, it seemed to work. So I said, why isn't it more important to figure out how a general therapy might work than trying to pin down genes? And now that we've mapped so many epilepsy genes, we're still not any more advanced with respect to any specific targeted therapy that can stop epilepsy in general, but the keto seems to do that for a significant number of people. And it was very funny because we were running cancer studies and epilepsy studies simultaneously in the lab. We had a series of brain tumors and we had a series of epilepsy mice, and actually the two fields were becoming more and more overlapping in molecular mechanisms. How is it possible that the keto therapy could diminish electrical excitability in the brain? What are the mechanisms involved with that? And then we found out that it was lowering the glucose, because if you didn't lower the glucose, and John Freeman told me that a long time ago. John said, listen, if you ever get a kid that really likes to take in large amounts of ketogenic diet, they invariably have no seizure control. And he says their sugars remain high. You got to restrict it a little bit or do something. And then we were looking at the tumors, and Otto Warburg said long ago that these tumors are driven by glucose. So we started lowering the glucose, and we got direct relationship between the lowering the glucose and how slow the tumor would grow. So we're looking at two phenomena here, the lowering of the glucose and the elevation of the ketones. And in one case, it was managing epileptic seizures. And in the other case, it was managing the rate of tumor growth. When I first entered the field, looking carefully at, I didn't know what Warburg had done, working in epilepsy and mapping epilepsy genes and doing genetics. It wasn't really part of what only the fact that I heard of this guy, because he was a giant in the field of biochemistry. Everybody used Warburg apparatus in this. What happened? I went back and carefully, as a geneticist, don't forget, I'm a trained classical geneticist, so I understand genetics. And the dogma of the time was cancer was a genetic disease. And if there was any metabolic issues, it was due to the gene mutations were causing metabolic issues. But Warburg was essentially sidelined in this whole. When Watson and Crick discovered the structure of DNA, the whole field shifted over there to the fact that we found DNA defects in cancer cells, and genes were coding for all these different things. And there's an elegance about the discovery of DNA. And I always say biologists have a physics envy. And they've had it for centuries. Physics is the pure thought, the pure science of the human mind. Physics has always been the most egalitarian field. They have an arrogance associated with them. And all other fields, even chemistry, is not as sophisticated intellectually as is the physicist. So when biologists discovered that DNA is and it was a very coded quantitative, it became a qualitative science into a highly quantitative science. Now some of the physicists started jumping into the biology field because now it developed a little bit maturity and sexiness about it. And the field just massively went into this, looking for gene mutations in cancers, thinking that this was going to be the management of the disease, because once we figured out what these mutations did, we'd be able to correct them and correct the cancer. This led to the Human Genome Projects and the Cancer Genome Projects, where we mapped every single mutation in every kind of cancer. And then it was so many mutations and so much complexity, they had to bring in the IBM Watson machine that could beat guys in chess and Jeopardy, and let him try to figure out the cancer problem. And no one told Watson, the machine, that cancer was not a genetic disease. So this poor machine is burning circuits and smelling the wires are burning, and he can't figure out what's going on. And his recommendations actually put cancer patients at risk, because there are a few oncologists that recognize this information was totally an antithesis to what was best for that patient. And the absurdity of the field is you're believing this ignoramus machine that to treat patients, and even some guys say this guy can't be right. But he can analyze a billion pieces of gene sequence in like 2 seconds. But that's okay if cancer is a genetic disease. But if it's not a genetic disease, it's a complete absurdity. And that's exactly what it is. And they were paying millions and millions of dollars to rent this machine out to the Broad Institute, all these different cancer centers to figure out this stuff. And it was a complete absurdity. I think ketogenic metabolic therapy is going to be an accepted process in managing the disease. I think it's going to come from the grassroots efforts, meetings like this, Charlie Foundation information. I think this is where the public will be educated, okay? Because at the top medical schools, barring a few individuals, a few mavericks that might want to introduce or think about this, it's not going to come from the top. It's going to come from the bottom, unfortunately, because there's too much other things, interests other than patient outcome that drive the big medical establishments. An academic institution, it's a pharmaceutical institution. These are very powerful forces to maintain the status quo. So, but in cancer, when you have stage 4 lung, brain, or whatever, you want to live, and you want to be able to take something that's going to help you. Right? And unfortunately, a patient comes in and says, I'm sorry, doctor, I'm not interested in your chemo or radiation. I want to do metabolic therapy. And then they get browbeaten or discouraged or ridiculed. There's no evidence to support this. Well, did you read the literature? A lot of these people are reading the literature before the physicians are reading the literature. And you have to understand, they're well-meaning people, but they've been not trained. They don't understand the biology of the disease they're working on. And that's a tragedy. So you're treating people based on therapies that are not related to the origin or the management of the disease. Now, you can kill cancer cells by poisoning somebody. I mean, you can incinerate their whole organ with radiation. And you can, you kill. But these poor people are put at massive risk for other kinds of things down the road. Why would you want to do that if you could achieve the same end goal with another approach? What's your interest? What is the primary goal? Is your interest in patient outcome? Or do you have another interest that's not more important than patient outcome? And I think that's the question that people have to ask themselves. What side are you on? Well, of course I'm on patient outcome. Well, why are you doing that? It's not related to the origin of the disease. If you're interested in patient outcome, why would you be treating a patient with a therapy not related to what the real issues are? Well, I've been doing that for a long time. What are the results? We have 1,600 people a day dying from cancer in the United States. In China, it's 8,000 a day. Okay, so if your stuff works so well, how come we have all these people dying every day? So we can drop that death rate by 50% in 10 years if we treat this disease as a mitochondrial metabolic disease. And those treatments will be working and they'll be effective. No question about it. The resistance, I think, is in the academic world primarily. Number one, people have invested their whole life into gene sequencing and studying signaling cascades. All the research grants are related in one way or another to this. NIH says on its website, cancer is a genetic disease. If you look at every single textbook, biology, biochemistry, cancer is a genetic disease. The field has been indoctrinated. It's an ideological issue. It's no different than a religion, a political affiliation. I believe that cancer is a genetic disease, period.